Somebody call Siri real quick.
Hey. Hello.
Hi.
How's it going? How are you guys?
Not too bad. I guess I'm like super busy, but that's why I don't you don't see me a lot on the channels. But I'm so sorry for that.
I didn't get why we don't see you that much.
Oh, I'm just busy setting up my own company, so it's just
Oh,
going
that's cool.
crazy right now. So
Coding and stuff?
yes, it's a software consultancy.
Very cool.
Yeah.
Well, I won't keep you long. I see the new guys aren't here.
I don't see anyone. Should I be seeing anyone, or is it
Yes,
just
you
sound?
should. I mean, it's better if you see.
Let me see.
If you double click the cloud recording.
No, don't.
No? Because that's what
No.
I did so I can see the screen.
Yeah, but you should click the where it says Viratrace and you see the stream, my stream. Then we are going to be able to see what I share, like the presentation and stuff. That cloud recording thing. Okay. That cloud recording thing is just something that I made to record things on Discord, like meetings and such.
Okay.
So if you would just click on my stream. So where right now it's the Discord screen, but if I share something, it will show up there, like the presentation, for example.
Okay. I see it.
Can you see this?
Yep. Secure Enclave, Firebase, the whole
Right.
app structure.
Well, I don't know. We can wait for Ivan.
Hey.
Hey, can you see the screen?
Yes.
Okay. Yeah, so let's get started. Like I said, I wanted to show you guys what I did to, justify spending the time for me if you think it's cool, and maybe get some feedback. I don't know. So let's get into it. You've seen this schematic. If you looked at the solution architecture page on our website, the text on that page is not related to this schematic. It's mostly marketing content, but we're going to talk about these components of the I don't want to say ecosystem, the system, the components of the system. So let's start with the thick of it. Let's start with this part here, which is what happens when the phone detects that it has been moved. So we get these 4 parameters from the sensor or from the firmware of the sensor, and we use the speed to establish how often we send updates to the server. So obviously the higher the speed, the more often we're going to send the updates. And then these 3, which is more like these 2, because the altitude is not the elevation from the ground level, it's the elevation from the sea level, which nobody cares about in this context. So we use the latitude and longitude to get the location, but the problem is the accuracy is very low. I mean, it's around an average of 14 meters, which is not great. But the good thing is the phone sends updates very, very quickly. So what we can do to optimize the communication between the phone and the server and not send so many updates and potentially, overcrowd the traffic, we can average out the location. Like if you have the phone still on the table, it will detect that it's moving and it will give you a bunch of points. Now, if you average out those points, if you draw a shape and average out those points, you will get a more accurate location. So we set the time interval anywhere between 5 and 30 seconds, depending on the speed of the phone at which it's moving. And the way it works is, just a second, I made an illustration. Yes, we work something like this. We get the location change method, and we get a point. Now, if enough time has passed since the last update, if the duration since the last update is equal or longer to the frequency, then we just send that point. But if not, we get another point. And we continue to do so until either, and we draw a shape, until either the duration is equal to the frequency or we reach 30 seconds, in which case we just we calculate the centroid and send that. And that way, we're able to get a little bit more accuracy and not send as many updates as the phone gets from the sensor. So once we have that point, we pack it into this data structure here, and we hit the server endpoint on this on endpoint positions. Once it gets there, the server checks to see if the UID, so this one here, if the UID exists in its database, because whenever a new app is instantiated, whenever there's a new user, a Firebase calls an endpoint on Apollo on the server to let it know that there's a new user. So this is also, it works great for security, because only if you have the Firebase generated token string, you can access Apollo. If not, if the UID is not found, then it returns this back to the phone or whatever sends that update. If it is found, it uses that in order to update attributes of this user object, which is last known position, which is the only position really that the user has. He just has, or they just have, last known position. And based on the last known position of the other users, it checks for proximity. Now, if it finds the proximity, it returns then to the phone the list, the number, and the list of proximities that it finds, and the phone displays it on the main screen. It says something like, you are 7 people nearby, something like that. And then it checks to see if that proximity or the proximities are pertaining to existing interactions. And again, we have 2 possible scenarios here. Either the interactions for those proximities were already existing. If any proximity is not associated with the UID of another user with an existing interaction, it registers that interaction. And if it doesn't find proximities, it ends all ongoing interactions. And when an interaction ends, regardless of which of the user ends it, it ends for both users, and interactions can only be between 2 users. So apart from this, operation that happens when the phone sends updates, on the server there are a couple of more things happening. Like I said, so the phones can post updates. the Firebase can post new users, so this, and then the server knows to accept that and register a new object. And then we have this method which returns all the contacts, which are actually the users with their contacts. And we have this right now, and we can have this if we run the infection model outside of the enclave, which is a possibility without any compromise to privacy. So you can have, once the locations have been, interactions have been accounted for within the secure enclave, you can just have the durations of, and the interactions objects exported and processed outside, depending on how intensive that operation is. Now, apart from the API, so these are things that happen when you invoke these things. You have some processes that happen independently. One of them is to create contacts. Now, contacts are the third object that are related to people being close to each other. The first one is proximity. The second one is interaction. All proximities become interactions, but not all interactions become contacts. For interaction to become a contact, what needs to happen is for every uninterrupted block of time, which is 10 minutes or more, half of that time has to be counted as ongoing interaction with a particular user. So let me explain again. So let's say 10 minutes. The reason for this mechanism is precisely because the location is not very accurate. So you can have two phones close to each other, and then the location can jump, and the location of one phone can jump 5 meters away, the other one can jump 5 meters in the opposite direction, and then the interaction would register as being over. However, if for 10 minutes you have more than 5 minutes ongoing interaction with that particular user, then we can count that as a contact. If that makes sense to you. So this is an ongoing process that accounts for the beginning and the end time of all interactions and adds those together in order to establish, to register contacts and adds the contacts to the users. And then, there's another process which disposes of interactions and disposes of the contacts, and also the last location of the users. If the users didn't update their last location for more than 30 minutes, then it's obvious that, it's very probable that the user just stopped the background location service on their phone, or the phone ran out of battery, and it doesn't make sense to continue to account for that user in that location and actually register interactions with all other users that are going by that location. And then, so these are ongoing, and then there's another process which is scheduled, and this is it calls a cloud function on Firebase to get all the users with their risks, which are updated either by the users of the web app or the users of the phones. So either by reporting symptoms and test results, or the users of the web app going in and manually reporting symptoms for the users of the phones. And so this is a three-step heartbeat, so to speak. It gets all the risks, it runs the infection model, which right now is just combinatorics, and it's then pushes the risks back. And on the other side, Firebase knows to listen to those HTTP calls for retrieving the risks and pushing the risks. So that's the server. Let's go on to Firebase. Are you still there?
Yeah.
Okay. On
Sorry,
Firebase.
one question.
Please.
I wanted
Yes.
to ask, and then I forgot. You said you explained how. Just to remember exact words, you explained how the interaction becomes a contact, right?
Yeah.
How does proximity become an interaction?
All proximities become interactions. But the reason why we need the difference is we don't want to register new interactions whenever we get an update from the phone. So that's why we need an intermediary, that data structure that we call proximity, so that we can check if that if that user has been there before and we just need to enforce the interaction object to keep it going, that's why
Yeah.
we
Okay,
need
makes
something in
sense.
between there.
Okay.
Yeah. So basically, when the proximity, if you find out that that proximity, there was already an interaction object for it, you just update the interaction object with the last time that it received an update, and the user, one of the two users who updated that, and that's what happens. Okay, so let's see about Firebase. There are a couple of things that we use on Firebase. We use a database, which is a NoSQL type of database, and it has three collections: users, symptoms, and results. Let's just look at that really quickly to see what it looks like. The database is called Cloud Firestore, and we have all the apps. So the web app, the iOS and Android all share the same database and share access to the same resources here in Firebase, which is really helpful. So like I said, we have three, if it loads. Yeah, the messages doesn't, that was just something that I tested, but the collections that we are using are these three: users, symptoms, and results. So for the users, we are storing, right now it's anonymous. The user authentication is not done with phones. We used to do it with a phone number, get a code, do all that process, but it doesn't project the idea of privacy, that process. So we're trusting the Google Play Store to filter out bots and emulators and all that stuff, because it turns out Google Play Store knows about all the actual phone numbers in the world, which are both on iOS and on Android, as long as they're using apps like Gmail and stuff like that. So it's not as secure as if we were to do the phone number thing with the OTP code, but it's a lot more, confidence inducing. And so we have the symptoms, which are basically, so for the users we just have the risks, and we have the risks and the UID. For the symptoms, the same kind of thing, and the risks is calculated on the phone itself based on the configuration of the symptoms. So if you have one symptom of the disease, two symptoms, or three symptoms, and the timeline when the symptoms occurred, that whole thing is just calculated on the phone, and then it just comes here as a number along with a date, so that we can do the gradation for the symptoms. For the results, we have a couple of more things. This is a Boolean of asymptomatic if the result was positive but without symptoms. We have a picture of the validation picture that the user takes. False or true is negative or positive test. So we just use a Boolean here, and when they took the test, let's see one which also has symptoms. So we have a date for when they took the test, and we have the date for when the symptoms started. Those are reported in the app. Now, if the symptom gets validated, goes through the process of validation from all the other users, label that picture to say, yeah, this is a picture of a true test result or not, then it will have these two fields here. One is pass, one is fail, and it will contain a number which represents the number of people who said that this is a picture of a real test result, and the fail, the other option. So this is a database in Cloud Firestore. Then we're using Cloud Function. We're using, like I said, one to send whenever there's a new user, that gets sent back to Apollo so that it knows to accept location updates from that new user. Then it sends all the users again just to Apollo when it calls as part of that scheduled heartbeat to retrieve all the risks, and then to push them back. It knows to accept. Then when after Apollo does its calculation to establish risks, it knows to accept those risks and assign them back to the database. And then there's a cloud function that triggers an alert on the phones. So through cloud messaging, it triggers an alert to tell the user that they have the risk increased. And right now there are 3 tiers: low, medium, and high. So low, not in the sense of lower than average, or in sense of there is some risk. In the other cloud function is to handle, so whenever someone sends us a message through that contact form on the website, that's a cloud function also to send it to the Discord bot and to Wayne's email address. And then we're using storage just for the validation images. So these things here, these are stored. This is an address for Cloud Firestore. What is it called? Storage. It's called storage. And we're using storage also for the images on the website, and for the assets in the. Some of the assets are backed up for the mobile apps are backed up in storage here. Crashalytics doesn't work, but it should basically show whenever the app crashes, it should show some stuff there. I don't know why it doesn't work. And then we're also using one CloudML function to parse the validation images through not safe for work filter, so that pictures of various body parts don't have to go through the people, reach the people who are trying to validate test results. So that's Firebase. And then there's another one, which is the web app. Now, the web app, there's nothing that doesn't, if you go and to sign in, you just get this window, but there's nothing there. But here's what should be there. So you should have some functionalities, and this is intended for the administrators of the communities in which the whole system gets deployed, right? So if you deploy it in a state, for example, in the United States, you would have the local government and the health authorities. And here's why. So whenever you instantiate a new Viratrace ecosystem, you have to provide examples of positive test results so that the users who go through the validation process will know what to look for. You have to provide it with the total number of users in that community and the status. The status is something that shows in the alerts or even in the main screen as it's just a message of the general measures that are being enforced. And depending on the percentage of people who are infected, you can have different measures and you want to show them in the app, like we're wearing masks both indoors and outdoors, just the status. Then it has a CRM like type of interface. It doesn't, but it should, where you can invite people, which you can set a percentile, the top, 5-10%, depending on how many those people are and how many resources you have. You can send them notification through the app to invite them for testing, or invite them to share their contact details so that the personnel can get in touch with them and figure out a way to get a test to them, right? So you can do that just from the web app. You send to the mobile app notifications. You cannot do that, but you should be able to do that. And you can also set the test results. Well, you cannot really set the test result, but you should be able, once you test somebody, if you perform the test, right? If you're the medical personnel, you should be able to manually set that test to positive or negative. You don't have to rely on that person reporting the test in their app, because you have administrator app privileges and you can do that. So that's the testing funnel. And then you should also have some analytics with that are showing, aggregate data about how, if the people are interacting more or less, how much of the population you have has adopted your system, and if the types of analytics that you get right now with daily actives and stuff like that. So this is the this is the web app, and the only thing remaining is the mobile app. Is this fairly straightforward so far?
Yeah.
Okay,
Are
let
you
me
sure
connect.
that it doesn't complicate things too much? These functionalities that require you to have backwards connection to the phone. So
Backwards connection?
So most of the functionalities that we talked about require you to have for a phone to know how to access data or its inbox on the server. But now when you are talking about letting users share their data with medical personnel, or those medical personnel being able to contact people, it seems to me like that would require way more data being shared about the actual user to be able to get back to them, to be able to make that connection back from the server to the phone.
Yeah, basically the privacy is out the window when you do that.
Okay.
Because so you have to agree, you have to, as a user, if you're at a high risk, you can agree to send them your phone number or something and get a test for free, I guess would be the the upside of this, and get tested. But there's no more privacy. Not sure why this is not connecting. Let me try it again. Okay. Can you see the screen? My phone?
Yeah.
Okay, so let's go into the app a little bit. I mean, yeah, even if, if it doesn't do all these things, the graphics are absolutely wonderful, I think. So you accept you cannot go into the app unless you provide the location. You allow, the usage of your location, and then once it starts, it takes just a few. The first update gets sent regardless of the speed, and then it receives. Okay, but right now it says it's seeing 12 nearby people because I manually set on our server points of proximity. This number, if we're gonna be here long enough, you'd see this number go down. I don't think it's gonna go up. This is the maximum, but it's gonna go down based on just how it estimates the location of this phone, even though this phone is not moving. So I set around the house, and those points are very precise. I sent a few points where I'm telling the server these are people here, and they don't expire. So based on this, I was able to basically estimate the location accuracy. And then you see proximity range, that's 15 meters. That's actually the accuracy of this location, but it's also the accuracy of the other users, right? So the idea is, based on the error margin that you have and the other users have, we can just use the accuracy as the proximity range, because the condition on the server is that the phones are closer than 3 meters. But that's going to fluctuate based on just how the phone interprets. Look, now it's changed to 8. Just how the phone interprets the data from the sensors, or the accuracy of the sensor. So yeah, I think you know most of what can happen here. Right now, like if we closed it, we don't have GPS enabled. However, it's accessing the GPS. So that's something you should be aware, just in general, that phones can do that. But we are required to have this the notification here that background service is running. A couple of things you can do. You can report the symptoms. Stop me if you've seen this. The symptoms of this virus, and then, like I said, the app calculates locally a risk number associated with the configuration of symptoms, so that it just sends a number back to Firebase. And of course, it asks you when the symptoms started, and this is going to be just for today. This is going to be, so today's 7th. We're only going to have one user with the symptoms. So let's, okay, this one. Because I just want to get the UID so that we can send a notification, show you how that works. I think I copied this. Okay. Just a second. Okay, so now I have the UID for this, and you can send symptoms. You can send active infection. This is not new. You take a picture. Okay. If you send this picture, it should get invalidated. You specify when the symptoms started, and then you basically check that the information is accurate. You get another, something to scare you if this is not genuine, and this is done. It should calculate, it should see the proximity again because it performs this. By the way, yeah, right now when it's doing all that stuff, it's not updating the strings it's not updating the visual elements for the proximity, but it does communicate normally with Apollo even when the app is not active. So that's it. Right now we have the just a second, this UID in the we retrieved it, and we can basically simulate what Apollo would do to push risks and how we would get that notification back on the phone. So I think I ran all of this. This is a more or less exact copy of the code on Apollo. And now, for example, we can call Firebase to retrieve all the users. Okay, this is not code. These are all the users in our database. So this is what Apollo would do. We can basically just, instead of the infection number, just add all add 1,000 to every user to their risk. That would trigger enough that the risk would be high enough so that when we push back everything, we push it back to Firebase, it will trigger a message to all the users say that they're at risk right now. So before that, if we just look a little bit at the risks associated with these users, so ours was this one, K2. It has 100. Yeah. Okay. So if we push now the updated risks, which is what our server would do. All is well that ends with status code 200, and it takes a little bit of time. But if we look at the functions, we can see that it did. Okay, so update risks. Let's see the logs. It should have called this function. Yeah, and these are the function execution finished with status code 200. It should, right now it's it should basically increase the risks. I waited it took as much as 5 minutes at one point until the function actually updated the risks. But the reason that I did this was to get to the point where it triggers the message, the notification on the phone, and basically you get the okay. Did you see that? They all went red.
Yep.
Did you see? That was quick, but did you see that they I don't know if I shared the other screen. Anyway, look, now the risk is 1100, and this should trigger the other function on the phone itself. Let's connect to the phone. Now we're almost done. I just want to show you that the notification went through. Can you see anything here? No. Oh. Okay, let's see. Why doesn't this connect? It just says connecting. Can you click on the, instead of this stream with my screen, just click on my webcam. Can you do that?
Sure. Maybe. Yeah.
Okay. So this is the phone. And now we have the notifications from our app, both for medium, high exposure risks, because it triggered all of them, which should be. And if you click on one, tap, it takes you back to the app. That's the demo. That's my time. Thank you so much. I don't know. What do you think?
Perfect.
Yeah, that was good. I am currently working on testing all of that on the iOS side, but everything seems to be working the way that it should. So it seems like the primary goal of getting something pushed out has been accomplished.
Yeah, it worked. I mean, the minimum functionality all the way back to notifying the user is there. However, you need a lot more than minimum functionality, I would say, to be competitive and compelling in the current contact tracing scene. But that's a whole different discussion. The main reason was for me to, I might have missed a lot of things in the way that I implemented this thing, and I just wanted to share it with you so that if you can figure out things that I didn't do so well, to correct them. And also, in the case of Vikas and Derek, to know how this works so far and what we've done so far.
Yeah, absolutely. Derek, Vikas, do you guys have any questions?
Or microphones? Anyway, if they do, I mean, I recorded this.
Well, they say they don't. They say they don't have microphone permissions.
They don't have microphone. I'm sorry. Just a second. Yeah, because I thought other people would join. Okay. Vikas has microphone permissions. Derek too. Go ahead.
You guys can unmute your microphone if you go into the stream. Still says Derek's suppressed.
I mean, I assigned him the core role, which is what we have.
Derek, I just unclicked server mute, so that should see if that helps.
Hello?
Anyway. Yeah, hey.
Hey, okay. So I had one question relating to like the next steps. So, what's like the current plan to, deploy the model, and what can we do to like improve it or work on additional features?
Yeah, so I'll share a backlog with you by Wednesday. But the idea is there are these things that I mentioned here that are not fully developed, like the mechanism for the web app, so the administrator side of the community, we did discuss a more accurate way of tracking interaction based on triangulating Wi-Fi's. I didn't do that either yet, so that's also quite early in the backlog as a functionality, as a story. And yeah, in terms of deploying, I don't know.
Yeah,
Anything like that?
Yeah, so I've been looking at that. We need to currently get in touch with our partners that are doing the secure enclave portion. I think now that we have minimum functionality, they're able to finish their work. So I'll be touching base with them this week, probably setting up a meeting at some point. Everyone here will receive an invitation to that. Additionally, we're reaching out to a few private businesses and state governments. The big one right now is the state of California. We've reached out to the governor in a few different channels. We're hoping to set something up there. We've submitted a meeting request. If we can get a meeting for that, I think we can get some support and get this deployed. Currently, the timeline is kind of slated or projected to be, release something viable by October 30th. that obviously is flexible depending on how the development process goes and how quickly we move. And other than that, it's simply a matter of getting interest in this and actually getting a customer before we can deploy anything.
Derek and Vikas, I did have a question for you guys. Actually, I asked you this in our first meeting, but for some reason I'm still confused about it. So, did you say that you were able to implement the whole Bluetooth proximity thing, and you didn't have any problems with the iPhones? You said that, right?
I think we had some issues with iPhones, but Android was. I think we were mainly testing on Android because we couldn't we didn't launch the app on the App Store, and none of us had a Mac to actually use Xcode on, so that we were mainly testing on Android because it was like a weekend project. So yeah.
Yeah, so the whole thing that I shared with you here, the whole mechanism for averaging out and creating a shape and doing that all is orders of magnitude more complicated than if we were just to use Bluetooth. And we could also account for elevation. Now, if we, on top of this, introduce the Wi-Fi triangulation thing, I mean, yeah, it can work, but it's so much more complicated than just retrieving the ID from the Bluetooth sensor. Much more complicated. If that were to work, it would be great. Problem is, it only works if you use so as far as I know, it only works if you use the exposure notifications, and it doesn't if you don't. Like the patch that the Apple made to allow the Bluetooth sensor to work in the background is associated with exposure notifications. But it would be so great to just use that. Oh, and anyway.
So didn't they say that they will also release this patch as a standalone patch?
I didn't hear that. Did you?
Yeah.
Okay.
Well, what they've done is they've expanded the exposure notifications API to essentially generate a white label app. Google currently has the functionality. iOS, something has to be developed or deployed separately. But essentially, when a user downloads an OS update for their device, it's running the new API. There's some more analytics and things that are opened up. It's still very, very restricted.
I don't understand, Wayne. I'm sorry. Did you say that they patched this up and it can work without the exposure notification?
No. So that was basically what Yvonne was saying, is that they patched up so you can work with it. That's not really the case. It's they've basically just done a system where they auto-generate an application that state governments can sign up for and use it. Kind of a white label thing. So the average developer still can't just utilize the APIs. They have to either be public health department or find a way to.
But we are not talking about these APIs. What Andre is talking about is a more low-level thing of accessing Bluetooth directly, not.
Yeah, as far as I know, that's not happening.
Yeah, I misremember them. Sorry. Yeah.
Okay. If there aren't any more questions, I guess that's what I wanted to show you. If at any point in time you think of some questions, you know where to find me. And
perfect.
Thank you.
Thank you.
Perfect. Thank you.
Thank you.
Goodbye.
Goodbye.
Thank
Thank you.
Bye.
Thank you.
Bye bye.